So if we have receptors, right, CB1 and CB2 for cannabinoids in marijuana, right, what are those receptors doing? What are they for? What is the endogenous, right, or the sort of natural, released neurotransmitter in your own nervous system that typically acts at these CB1 and CB2 receptors? Well, it turns out that there was a hunt on immediately as soon as they had identified these receptors, and we have discovered what are called the that means the body, right? The body's own cannabinoids, right? So there are, neurotransmitters that are going to be released. It'll be upon the arrival of an action potential, and they will, respond or act at CB1 and CB2 receptors, both in the central nervous system and the peripheral nervous system. Turns out that the endocannabinoids are derived from this compound that's called arachidonic acid. Now, arachidonic acid is a fatty acid. It's a lipid, okay? And it actually is found in your cell membrane. So remember, our cell membranes of every cell, right, are composed of that phospholipid bilayer with the proteins embedded in them, right? Well, it turns out that intercalated or stuck between these phospholipids are molecules of arachidonic acid, okay? They're present in the membrane of every cell. And there are two, specific endocannabinoids, neurotransmitters that are going to be cannabinoid neurotransmitters that are released, in your nervous system. One is called anandamide, and anandamide comes from the Sanskrit, the Indian Sanskrit word ananda, which means, quote, the joy without which the world would not exist, or another kind of translation is bringer of inner bliss and tranquility. And this acts, specifically at CB1 receptors. There's another lipid cannabinoid receptor, actually, that's derived from arachidonic acid that's called 2-AG, and less is known about the effects of 2-AG at the moment. I have a question, though, here, and I want you to think about this, quite seriously. Why can't we store anandamide and 2-AG in vesicles? Typical neurotransmitter, of course, is packaged into vesicles, right, via transporters, vesicular transporters, right, which shove, that neurotransmitter in against the concentration gradient force, and then, the vesicle binds, with the presynaptic membrane upon the arrival of an action potential and releases the neurotransmitter into the synaptic cleft. Well, that cannot happen, right, with cannabinoids. The reason is because these are lipids. These transmitters are actually fats, so they slip right through membranes. They might stick in the phospholipid bilayer of the vesicle, but they won't be held in it. They can easily slip out, slip in. They can't be stored in a typical vesicle because they are fats. So it turns out that upon the arrival of an action potential, right, there's depolarization of that axon terminal, okay? There's the opening of those voltage-gated calcium channels. That still happens. The calcium enters, and in neurons that are going to release cannabinoid neurotransmitters, there's an enzyme that's activated, right, that'll cleave off anandamide and 2-AG from arachidonic acid, and then it'll leak out, through the membrane into the synaptic cleft.